Okay, everyone, I promised a video about how to do this confidence interval homework, so here we go. So to recap kind of what we talked about, we've been looking at sample means, where we take a bunch of different samples and we calculate the sampling distribution of the means of each of our samples to kind of figure out what the true mean of the population would be. So in this case, we're looking at a coffee machine that fills up a paper cup, and you're supposed to get 10 ounces of coffee. And as you can see, there's always natural variation, and you can see that some are over, some are under, and we're trying to figure out, what is the actual average that this machine produces. These are only 20 samples. So before you make a confidence interval, remember you have your acronym PANIC. So let's talk about what P, A, and N stand for before we jump over to the calculator. So here for P, it's kind of redundant, but we say whatever we're doing. So the parameter is always going to be, in this case, a confidence interval. Make sure you mention the amount of confidence. And again, I'm going to talk through all of these. If you want to pause and just write them down, you can, but feel free to pause at any time, but I'm going to keep going. So again, what's our P? What's parameter here? We are creating 95% confidence interval to determine the true mean amount of coffee poured from this machine. Now your assumptions and conditions, remember for sample means, still checking if they're independent and random. I think it's safe to assume that each pour was independent of the other. It's a machine, and they were done randomly. It says so. Over here, we can argue that 20 cups is less than 10% of all cups poured. Now, the nearly normal condition, that's the thing that we talked about yesterday in the video, where you have to check a histogram of your data. And the smaller the sample, the more normal and better look. The larger the sample, the less important that is. So in this case, we're going to have to go check that out. So this data right here, this is going back to Unit 1, beginning of the semester. You would enter this into your calculator. And from there, you can make a histogram. You can make a confidence interval and all the things we're about to do. So first, let me just remind you how to do that. We're going to jump over to our camera. All right, and here's a calculator. Da, 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 da. All right, so we're going to turn it on. Now, if you remember, if you go to Stat and Edit, List 1, I've already entered in the 20 data points. So once you've entered them in, if you remember from first semester, to see a scatter plot, to see any plot, whether it's a histogram, box plot, scatter plot, etc., we go to second y equals, and we would click on the first one. Make sure the word on is highlighted. Yours might be defaulted to off, so just make sure you turn it on. Now, of all these options, the third one is a histogram. The list you're picking from is L1. Now, in this case, you might want to make your own window, and that's what I did. So I chose a window that started at 9. I believe that was the lowest we had. I went all the way to 10.4. I went a little past our largest amount, and the scale was only 0.2. Because most of these are between 9 and 10, so I didn't want to count by too much. And Y-min, you can always make 0 for a histogram, and I made the max 10 because I know in any one of my bins there's not 10 cups of coffee. And to see what this looks like, go to graph, and there we go. So you can see it's unimodal. It might not be perfectly symmetric, but that's a pretty good sampling distribution. I would say that's unimodal and symmetric enough that we can say this is from a nearly normal population. So that said, that's where the end part of PANIC comes in. We'd say all of our assumptions and conditions were satisfied. We can proceed with a one sample T interval. Now this part, again, we're just going to use the calculator. You've seen how to do it by hand. That was in yesterday's video, but let's just get to the point, shall we? So back to the calculator we go. Okay, the good news, you've already entered your data. So now if I go to Stat, I go to Tests over here. It's not called one sample T interval. It's just called T interval. It's the 8th option. So that's the one we're going to pick, T interval. And what you saw in the textbook in the video, but now you'll see in person, if I knew the summary stats, like if someone had did this ahead of time and said, hey, the mean is this, the sample standard deviation is this, I sampled 20 cups, we would just type that in. But we're going to go to data because we actually typed in data. And what's cool, it just asks you what list did it come from and what confidence. Here we go. So this number right here is or this interval rather, is gonna represent what we're looking for. So you can see here, the mean of our sample, 9.845, the standard deviation of our sample, 0.1986, 20 cups, and there it is. So 9.752 and 9.938. All right, that is what our confidence interval is. So let's write it down and then interpret it. So I'm gonna try and remember that. 9.752, 9.938. All right. I think that was it, if I'm not mistaken. And let's double check. Oh, 9.938. Woo! Okay, so now let's interpret it. So what that means, remember, we can be 95% confident the true, why is it doing this weird zoom out on me? We can be 95% confident the true mean amount of coffee that's poured from this machine is between our two interval numbers there, which would be 9.752 and 9.938 ounces. All right, now remember, you were supposed to be getting 10. So when it says, is there evidence to suggest this machine is underfilling cups? Yes. 10 isn't in our interval. All right, so again, 10 ounces isn't in our interval. Thus, this would suggest the machine is underfilling. Now, if we had done a hypothesis test, which isn't really in this homework, but just so you know the mechanics of it, I want you to think about what this means. So go ahead and take a pause if you want to write down, but I want to talk about our result here. So you're basically saying it's underfilling. But remember, if you had done a hypothesis test, you probably would have said the null is that it is 10. The alternative is that it's less than 10. So you would actually be choosing to reject the null in this case. So let's see if that holds up. I just want to show you on the calculator what this would look like. So if I go here, we've already entered our data into list one. If I were to go to stat, tests, and just go to t-test, that's all we're doing. Now see how it says input. Do you want to input summary statistics or data? Well, data. Now, here, mu. Well, mu naught, if you will, what's the average we're hypothesizing it is? Well, assume that everything's operating as it should, 10 ounces. And your alternative, we think it's underfilling. So your alternative hypothesis is that it's less than 10. And if we calculate, you can see right here, your test statistic, negative 3.5, and the p-value of 0.001. So that's pretty obvious that you would reject the null and accept the alternative in this case, that there is evidence it's underfilling. All right, so what do we do if it's a question where you're given the summary statistics? And that you can see with the third example. So I'm going to skip down to number 3. So it says here, a professor at a large university wants to analyze if kids are taking the recommended 15 credit hours per term, and a random sample of 245 students reveals the following summary statistics. So first, just like before, what are we measuring, or what are we finding? We're finding a 95% confidence interval to determine the true mean number of credit hours students at this university are taking. Are your assumptions and conditions met? Yes, this is independent. We can assume that the kids in this class, and again, maybe not. I mean, you could argue if they're all in the same professor's class, maybe they all have the same major or something similar, but it's okay to move on from this because 245 is definitely less than 10% of all students at this university. Now, notice here, I didn't just write carte blanche, write a check by everything. It's not exactly random. He sampled or she sampled her own students. So maybe they did so in a random way. Maybe they teach more than these 245, but they all did come from the same professor. So we'll just proceed carefully. That's all you can do. Remember, you're not just going to shut the problem down, but you do want to acknowledge if something a little unusual happens. Now, what's different here? Nearly normal. We don't have data like before. We can't make a histogram of this. So what yesterday's notes tried to explain to you was, if you can't check your histogram, if you have, now it's, some things say n has to be greater than 30, your textbook says 40. Once you have a sample that, we'll stick with 40, that's what your book says. But if you have a big sample, the bigger and bigger and bigger and bigger the sample size gets, the more likely, or central limit theorem just takes over. And central limit theorem says no matter what population you pull your sample from, with enough samples and with a large enough sample size, and we have 245 in our sample, the central limit theorem will basically say, doesn't matter what population it came from, a sampling distribution of sample means will be normal. So even if we don't know the actual data, it's safe to assume that with the sample this large, we're good. Central limit theorem says it's normal, you're good, nothing to worry about. So with that said, I think it's safe to assume we can move on. So again, for n right here, what would we say? We would simply say assumptions and conditions are met. Proceed with, again, it's just called a t-interval, but if you want to call it a one sample t-interval, you can, because next video we will be talking about two sample ones. All right, so in this case, a little less to type in. You're going to go to your calculator again. You're going to pick the same test that you did before, but a little different how you do your input. So stat, tests, t-interval, remember that's option 8. And you're going to go stats. And you can see here, this is where you'd put in the sample mean and the sample standard deviation and the sample size. So remember, 15 is what we're hoping for. Oh no, sorry. Hold on. I was jumping to a hypothesis test. In this case, it was 16.63. My bad, 16.63. All right, 16.63, 2.22, and the sample size was 245, and it was 95% confidence. So you don't have to enter all 245 pieces of data. Someone very politely summarized it for you. And if you go to calculate, there's your confidence interval. So between 16.351 and 16.909. All right. I don't know if I'm going to be able to remember that one off the top of my head. Let's see. 1 and 16.909. Okay. So again, this right here is pretty much saying that they're probably taking more than 15. So again, we can be 95% confident the true mean number of credit hours being taken by students at this university. And again, we're making this claim about the population based on this sample. We're hoping this professor did their due diligence and this sample is representative of the entire university. We can be 95% confident the true mean number of credit hours being taken by students at this school, apologize for the bad handwriting, is between those two numbers there. So it's between 16.351 and 16.909. So again, when they go to this next part, and it says here, the professor has believed that students typically take more than the recommended 15. Does this confidence interval support or refute her hypothesis? This certainly supports it. Again, we are 95% confident students are taking much more than 15. So if you're 95% confident students are taking between 16.351 and 16.909, 15 is nowhere near there. So you would definitely support their claim here. Now, again, had this been hypothesis testing, which I was not asked of you in this case, but I just wanted to show you how these two reinforce one another, you probably would have had a null saying something like mu equals 15, and then the alternative, the professor thinks it's more, so you would argue this. And again, if you just think about what you discovered, would you reject? No way. You would definitely reject H naught. There's convincing evidence kids are more, following that alternative than they are the 15. And let's just prove it. Let's see how low of a p-value you'd have in this case. So let's jump over to the calculator one more time. And again, you can do hypothesis tests with summary statistics as well. So if you hit stat, go to your tests, and pick the second one, t-test, you would have said stats. The null in this case is 15. That we're assuming the status quo. Now, you have this information, it's already typed in for you, and your alternative is that it's greater than the null. And you can see right here, your test statistics 11.5, and even if you're not super familiar with the t curve yet, it is close to the normal curve. I think we can agree regardless, 11 is a huge test statistic. And more importantly, this is 5.1 times 10 to the negative 25th. That is an insanely low p-value. You would definitely reject the null in this case. So I hope that helped you understand how to do these two questions. That leaves you with number 2 to try out, but I think you're armed with enough information to help you. And again, look forward to the next video where we talk about 2 samples and how to assess confidence intervals and hypothesis tests for the difference in the means of 2 samples.